Hello friends, today we will try to learn about exponential change in population. In previous lecture we have discussed about geometrical change in population or geometrical model of population growth. So today we will try to understand about exponential change. In reality, population change may occur almost continuously, not just at yearly interval. So like in earlier model we have discussed about population growth in such a way that we have considered population of 2001, then we directly have considered population of 2011, and we have calculated the growth rate. But in real world situation, population never grow in this fashion. Population grow at every interval of time. New population may add in every minute, every second. Recognizing of this led to a focus on exponential growth, which more accurately describes the continuous and cumulative nature of population growth. So it refers to the situation where growth compounds at every instant of time. As we have discussed earlier also, in every instant of time a new member may be added to the population. So population grows continuously, and whatever rate we calculate, we have to calculate the rate considering this situation, that in every instant a new member is added. Before going to exponential model, let us try to understand this first. This is the exponential form, like 7 to the power square equal to 49, 2 to the power cube equal to 8, 2 to the power 6 equal to 64. This is called exponential form. We often use this type of equations day to day, mathematical expressions. We also come up with this type of expressions which is also called logarithmic form, that is log base 7 49 equal to 2, or log base 2 of 8 is 3, or log base 2 log 64 with base 2 is 6. So what it means is that this equation asks the question of what will be the power of 7 to become 49, that is log 49 base 7, 49 it is 2. So here we usually express the power to become 49. So similarly in this case, what is the power of 2 to become 8? So it is 3. This exponential form we used to express in logarithmic form in this way. So the most common logarithmic form is the base 10 here. So what is the power of 10 to become 10? It is 1. Sorry, what is the power of 10 to become 100? It is 2. What is the power of 10 to become 1000? It is 3. So this is the most common logarithmic form where we consider base as 10 here. So where it is actually used, suppose our number is too large to plot it in graph, it will not come in the graph. So we have to express or convert it into logarithmic form, then it will come as 1, 2, 3 like this. Then we can easily plot that number in the graph. There is another logarithmic form where the base is not 10 but the base is e. So log base e. That type of logarithmic form is called natural log, which is also indicated by ln. So log 20 or with base e equal, we can also write like this, ln 20. So this question is what is the power of exponent to become 20. So we'll try to find out the value of e later on in later slides. So this type of logarithmic form is called natural log. Why it is called natural log? Because this type of expressions can be used to express most natural form of some kind of growth here. So these are some of the properties of natural log. Natural log of 1, that is, you can also write this one as like log base e1. So what is the power of exponent e to become 1? So as we know that anything to the power of 0 is 1, is not it? So exponent to the power of 0 is 1. So that is why ln 1 equal to 0, because the power of e is hidden here, ln 1, so e is hidden here, e to the power 0 is 1, is not it? So that is why this ln of 1 is 0 here. So what is the power of e to become e? So as we know that anything to the power of 1 is the same thing, e to the power 1 equal to e. So here ln of e is equal to 1. The another property of natural log is what? Ln of ex to the power x. So what is the ln of exponent to the power x? Here e is hidden, So what is the power of this base e to become this? The power of e to become e to the power x is what? X itself. Ln e to the power x is equal to x. So these are some of the properties of natural log which we often come across and which are quite useful to remember this. So logarithms are useful for solving equations in which the unknown appears as the exponent of some other quantities. So let us try to understand how to calculate the value of e. So what is e actually? Let us try to understand. Now if you remember the compound interest formula, suppose you want to deposit an amount of 100 rupees for 1 year, okay, 0 to 1 year. Now the bank is giving you an 100% interest, the maximum interest they can provide. So in 1 year, how much you will get as return? This 200, because this 100 rupees you will get back and your interest rate is what? 100%. So 100 of 100% is 100, so total 200 rupees. This is a simple compound interest formula. So we have never considered the growth in between 0 and 1 year. So the formula is what? 100, 1 plus 100 by 100 to the power 1. Now let us consider this example where we have divided the year into two parts, t equal to 2 here. So what will be the growth rate? Now our interest rate has been changed into 50 and 50. Why? The bank is giving you 100% interest, but here as the time is divided into 2, so they have broken the interest into two parts, 50 in one part and 50 in another time interval. So what will happen? Now you have deposited 100 rupees. Now after 6 months in first time interval, you will get back the 100 rupees plus the interest, the 50 rupees. So what will be your amount? Your amount will be now 150 rupees in 6 months. Now in next 6 months, 150 rupees plus the 50% of 150. It is 50 plus 25, that is 75. You can also do like this. Like what is the total of this is 150 rupees you will get back in what you call end of the year. Now you can break up the interest of these two amounts. So what is the interest of 100? It is 50 in next 6 months. What is the interest of 50? This is 25. So if you sum up, then you will get 225 rupees. So your amount has been increased. Earlier when you have only one time interval, so you get back 200 rupees at the end of the year. Here as you have broken the time into two, your interest rate is also divided into two, 50 and 50. So you will get back an amount of 225 rupees. So this is the formula, 100, this is our principal amount, 1 plus this is the interest rate in percentage, that is why we have divided by 100. And what is our time interval? It is 2. Now let us divide the time into 4 intervals. So if you do the math, you will get back how much? 244.140625. So it is again more than this amount where you have divided the time into 2 intervals. So how it works? So initial amount 100. So as you have divided the time into 4 equal parts, so your interest rate is also divided into 25, 25%, 25%, 25%. So in first quarter, you will get back 25 rupees as your interest. So your total amount will be 125 in 3 months. So 125 in next 6 months, or so in next 3 months you will get again 25% of this 125, that is 6.25 and 25. This 25 comes from 100 and this 6.25 comes from this 25. 25% of 25 is 6.25. So similarly in next 3 months you will get back how much? 156.25 plus these are the interest, and in next 3 months you will get back what? This much plus these are the interest. So a total of what? Rupees 244 you will get back. The amount increase as you have divided the time into 4 parts here. For the formula for this last condition is what? This is the principal amount under bracket 1 plus 25 by 100. 25 is your interest rate in percentage. To the power 4, 4 is the time interval. So suppose the principal amount is rupees 1. Here we have considered 100, but Let us consider it as 1 rupees. So this is the compound interest formula. So 50% of R means 50 by 100, this is 0.5. We can also directly write what? Pt equal to P0 is 1, under bracket 1 plus R is what? Suppose we have considered 50, then here we can consider 0.5 to the power. Suppose we have considered time interval as 2. Or also we can write like this: 1 under bracket 1 plus 50% divided by 100 to the power 2. If you consider R in percentage, then we have to consider like the formula like this. So let us have an interest at every month. So the T will be what? 12. So interest at one time duration is 100%. Interest at 12 time duration is what? 100 divided by 12. Is not it? Now putting into the formula here, A equal to P under bracket 1 plus, this is the percentage in 12 time duration, divided by 100 to the power 12. Now if you do this equation, then the equation will come up like this: P equal to 1 plus 1 by 12 to the power 12. Now we have considered here the time duration as 12, is not it? So we can consider any time interval here. So let us consider n time interval, then formula will be what? P 1 plus 1 by n to the power n. So let us consider P equal to 1 here in the formula. So time interval, let us consider time interval in this fashion. We have considered time interval as 1, then amount we will receive after end of the year. So equal to, divided by, what is the time interval here? 1. Equal to 1, then next equal to 1 plus 1 by n, then 1 plus 1 by n to the power n, equal to this to the power 1. So we will get back rupees 2 at the end of the year, is not it? So let us consider time interval as 2, then equal to, similarly if we consider time as 3, so let us do it for 4 also. So we can extend this up to 100 also, no problem. Let us check what will happen. At further larger number, let us check what will happen. Same value will come. Suppose let us consider this value 2.718. This value 2.718 up to this is not changing from this 10,000. It's not it. Suppose we had greater number 2.718. So from these calculations we come up with an understanding that whatever time interval we consider, it will increase up to certain level. Suppose up to here 1000, the final amount we get back is 2.7169. then when we increase the time interval into 10,000, then we'll get back 2.7181459. then further we increase the time interval, this value 2.718 is not changing. More time we added in our time interval, the value after 8 will change, but up to 2.718 it doesn't change. After crossing certain limit of time, this value doesn't change. So this value 2.718 is considered as E. It is the maximum possible result after continuously compounding 100% growth over one time period. So E is the maximum possible result or maximum amount you will get back if your principal amount is 1 and you have been given maximum amount or maximum interest rate, and if the time period is compounded continuously. This is not just 1 lakh time period, but a continuous time period, then also you will get back only 2.718. Here we have considered 2.718 only up to this decimal point. We have very large decimal points even after 718. So it is an irrational number. It is also called Euler's number. So we are not compounding for 1 or 2 time period. We are compounding it for continuous time period. Let us now try to derive the exponential growth formula using the value of Euler's number E. Now for that, let us consider that rate of change in population is equal to what? Rate of birth minus rate of death. We already know these things. So suppose you have a population number, suppose 1000. Now we have to calculate the growth rate for 1 year period. So every day new members are getting added and some members are getting eliminated due to death, is not it? So that is why rate of change in population is rate of birth minus rate of death. And we also have, let us consider or assume something like the population is sufficiently large so that we can ignore the difference between individuals. We assume that birth and death are continuous in time. Every day, in every second, someone may born and someone may die. Let us consider this because population growth is a continuous process. So there is a continuous birth and death going on in that population. Per capita birth and death are constant in time. Immigration and emigrations are ignored, and let us consider xt, population size at time t. So at time t equal to 0, x is x naught. Beta is per capita birth rate per unit time, and alpha per capita death rate. Now rate of birth at time t is what? Beta xt. This is the rate of birth at time t. Rate of death at any time t is what? Alpha x. Let us do these equations like this. So dp by dt is equal to beta population t minus t. Here in place of x we have considered p to understand that p is the population at time t. Okay. So dp by dt equal to beta into population at time t minus alpha at population at time t. Rate of birth at time t and rate of death at time t. That is the change in population or population growth rate. P is common here, population at time t, population of time t. So beta minus alpha whole bracket p. Now beta minus alpha is the growth rate. Birth rate minus death rate is growth rate. Beta minus alpha to the bracket p. So if we rewrite this equation, then dp by dt equal to rp, where r is the growth rate at time t. Now multiply both sides of the equation by dt. Then dt into dp by dt equal to rp dot dt. So dt will cancel out. Then dp equal to rp dot dt. Again divide both sides of the equation by p. Then dp by p equal to rp by p into dot dt. This one. Do integration in both sides. Then we get result of ln p equal to rt plus c. Now just consider the exponent of ln p. Then the equation will come up like this. Now this e to the power ln p is equal to what? Or let us understand in this way. Just consider this part. So ln p or ln. So the question is, what is the power of e to become p? Suppose ln p can be written as ln base e p. Suppose this is equal to x, which means e to the power x equal to p. E to the power x equal to p, is not it? So ln p means what? X. Here ln p means what? X. So ln p means what? X. So in this equation, if we consider e to the power x, because ln p is x, then e to the power x is what? As we have already know, e to the power x is p. Now what is e to the power rt plus c? So according to algebra, x to the power a plus b equal to x to the power a into x to the power b. So similarly here we can write down e to the power rt into e to the power c. We can just convert this equation into this way. Now e to the power c is c only, as it is a constant, so we can write down c into ert. So here these equations will end up as p equal to c into ert. So here c is the principal or constant. So mathematically we can write down pt equal to, in place of c we can write down p naught equal to e to the power rt. So this is the formula to express the exponential population growth. So from this formula also we can project the population. Suppose PT is the year for which we want to project the population, P0 is the base year, e to the power RT. From these equations we can also calculate the growth rate, like if we do the algebraic equation, then PT by P0 equal to e to the power RT. Now if you consider natural logarithm on both sides, then ln P by PT equal to ln e by RT. As we know the property of exponent is what? Ln by e to the power RT is RT. So RT here, then ln PT by P0, this T comes up from this side T. So this is the formula for what you call exponential growth rate. The exponential equations come up like this: 2, 4, 16, 2, 5, 6, like this, doubling every. The graphical representation used to be like this in exponential growth rate. So let us calculate the growth rate using this formula of exponential growth, 1951 and 61. So first PT by P naught, we'll do that first for 51 and 61, equal to what is PT here, this one, divided what is P naught, this one, equal to this value. Next what? ln, natural log of PT by P naught, so equal to, just write down ln here, then this natural log will come, then consider this value and bracket close. This is the natural log of PT by P1. Then again equal to, what is the time interval here? T is what? 10 here. So this is our exponential growth rate between 1951 and 1961. So in this way you can calculate the growth rate for other year also. Now how will project the population for 2021? Then you have to use this formula again here. So what is the value of R here? This one, so it's RT, then e to the power RT, then final formula P naught e to the power RT. So equal to, what is the value of R here? This one, into what is the time interval here? Our 10. So this one. So what is the value of E? 2.718 to the power this value. So then equal to, what is P naught here? We have to consider a population of 2011 into this value. So our population will be 36554, almost equal. So this is the population of 2021 calculated using exponential growth rate formula.